Hey everyone, Don Maeda here with TransWorld Motocross. We are in front of the Oakley headquarters here in Foothill Ranch, California. Actually, a couple weeks ago I got to pay a visit to the guys here and they took me for a tour in the Oakley Testing Lab and showed me some of the tests that the goggles and eyewear are subjected to and some of the different standards that there are for CE and military approvals. And it was actually really cool. I learned a lot and I was blown away by a lot of it. And in the time since, I've been telling a lot of my friends about it, and so I was thinking, hey, why not share it with the readers? So we're gonna go in and recreate some of it, so come on, let's check it out. Okay, so we're deep inside the Oakley headquarters in the testing laboratory with my friend Wayne Chumbley, who is the Vision Performance Testing Manager?
Yes.
Ooh, got that right. Okay, so it's been about 2 seasons now since the Oakley Air Brake goggle has been introduced. It's the most high-tech goggle available in motocross. It's also the most expensive, but technology comes at a price, right? So,
yeah, absolutely.
What inspired Oakley to develop a product that far advanced?
Well, for us, there was some very well documented cases of goggle failure. Our product as well as competitor product, and we do our best work really when we have to solve a problem. And we felt, very confident that we can solve some of the goggle failure issues when it comes to lens penetration, lens ejection, lenses collapsing on your face, and really that led to, essentially solving a lot of the other problems that come along with goggles like lens interchange, right? So we made a quick release lens interchange. If your foam breaks down, you got to throw your goggle away. So obviously our faceplate is removable and you can just get a new foam package. You don't have to destroy your goggle, replaceable straps, things like that. Way better anti-fog. Fogging on the gate is miserable. Fogging after you tip over or something is miserable. So our new lens platform allowed us to really look at the entire package and engineer and develop a goggle that really addresses all those problems.
Okay, so the most distinctive thing about air brake, in addition to the way the lens bolts on or snaps on, is how thick it is. Mm-hmm. So I know that the thickness of the lens is a direct result of some of the testing that you guys have done here, and I understand that you've adapted that style lens into the Mayhem Goggle, which is it was my favorite goggle previously, and the one with the nose piece. Mm-hmm. And it's more of a traditional goggle, and so it's now that's going to be in the Mayhem as well, right?
Yeah, correct. So if you think about a traditional goggle, it's a flat sheet of, it's commonly called Lexan, and you basically curve that flat sheet into a lens or into a frame, and you have your motocross lens, right? So what we did is we injection mold a polycarbonate lens. It's essentially twice as thick. And we mold it in the proper curves to correct the optics. The thickness gives you that added protection from impacts.
So a molded lens in the proper curve provides better vision than a flat lens that's bent into a frame?
Absolutely, absolutely, drastically different. And it's super noticeable when you go back and forth. I think your experience recently going back and forth, you're like, wow, there is a massive difference in vision.
Yeah. So can we check out some of the testing?
Yeah, for sure.
Okay, so we're at machine number 1, which is the ANSI and CE approval.
Yeah, this is what we call a high velocity impact tester. It'll test for a couple standards. Really, to sell goggles, you need to meet an EN 1936 standard, which doesn't mean anything to you guys, but it's essentially a 100-mile-an-hour impact with a 1/4-inch steel ball, right? We internally test to an ANSI standard, which is a little higher velocity, 250 feet per second, which equates to 170 miles an hour. Great test. It's real simple. It's pass or fail. And when we show you this test, you're going to be like, oh, it's pretty violent. However, we're still seeing failures. We're seeing goggle failures in the field. We believe this test is nowhere near the type of impact that you receive off of 450. So I'll show you this. Okay, 1/4-inch steel ball. And once again, we're going to fire this guy at roughly 170 miles an hour.
You ever have any human volunteers to put their head in there?
None yet. Actually, Joseph is recovering just fine. Okay, so you're gonna want to look right at the goggle here. Okay, everything's measured in feet per second, so pretty much right on the standard. 247 feet per second is essentially right on the standard. And if we look at this goggle lens, you'll see we definitely have some damage.
It's dimpled in there.
Yeah, it's dimpled, the lens flexed a little bit.
So this is a Crowbar, which is a standard, normal type.
Standard Lexan lens, right? So if we look at this and we correlate this to what happens in the field, you've probably taken plenty of shots to the face and your lens doesn't come up that dented, right? So we know when we have a catastrophic lens failure or the lens ejected from the frame, it's a much bigger impact than this. And so this is the new Mayhem. We'll do the same test here.
So this is the Mayhem Pro, which has the...
And this is the new lens platform that we launched with air brake. And we didn't do anything different than Mayhem other than offset the lens keyways a little bit, groove thickness to accommodate this thicker lens. So same fit, same chassis, same ID, just a much safer lens. So if we look at the difference in damage between the two, we have a pretty obvious dent, and we have what looks like a little scratch here. So if I was a goggle developer, designer, engineer, and this is my pass-fail criteria, here we go, let's sell you some goggles. And that's essentially what the industry does. That's what we did for years. This was our testing criteria. So if we step it up a notch, clearly that test standard, again, is not very applicable to what's happening in the field. So if we step it up to this guy, this is really what's known as a military or a V0 standard, where we're going to shoot this projectile here. Now this guy is not nice and round and smooth. It's got some sharp edges to it, maybe more like a rock.
So this is military test standards because Oakley actually produces eyewear, safety eyewear for the military, correct?
That's correct, yeah. And the reason why this is a military standard is they believe that if a bomb explodes and you have metal shrapnel flying through the air, it's going to be about this size. It's going to have nice sharp edges to it, and we're going to shoot that at roughly 650 feet per second. So big increase in velocity. That equates to roughly 440 miles an hour. So give me a second, I'll set this guy up. Okay, we're good here with pressure. If we see this laser here, that's exactly where we're going to hit the lens. Now, again, this is an elevated impact, so we expect to see a little more damage. And if you guys are ready, you will definitely want to film that lens. So, okay, ready? Okay, you still see what appears to be a dent in the lens, but the reality is that projectile went all the way through the lens, into your eye, and probably your brain. But also the reality is we don't see this type of failure in the field as well. We don't hear about guys with a complete puncture through the lens, right? So while this is still a valuable test, it's not really reality. However, with better materials and better goggle design, we can still meet this elevated impact here. So we'll shoot, and this is the Mayhem Pro, obviously with the impact resistant lens. And that projectile bounced off of the lens there.
Okay, so how many miles per hour was this test then, would you say?
So the standard's 650 feet per second, and that equals 443 miles an hour.
Okay, wow, that's much more violent than the first test. Where does a 450cc dirt bike fit into this equation?
Yeah, it comes in a little bit lower than that, and I'll let Jeremy Swan.
Let's meet Jeremy Swan. So, you look like a math guy, so. Okay, so how does a 450 dirt bike rate compare these two bikes as far as how fast it can throw a piece of roost?
Well, manufacturers like to publish how fast all the torque values, and we found out that on average between 7,000 and 8,000 RPMs is the maximum torque, roughly about 30 pounds. With that, using the size of the wheel, we can calculate we can estimate how fast a rock can be traveling.
So how fast can a rock be shot off rear tire of a KX 450 set?
So doing that, something about this weight, be shooting about 300 miles per hour.
Which is closer to this one than that one.
Yeah, way closer.
So it is possible to blow through a lens with a dirt bike.
Could be, yeah.
Scary. Okay, so that was pretty cool what he told us about the 450 and the way you guys calculated the potential for roost off the back tire. Earlier, you did say that there's not too many failures where something penetrates a lens. Most of it is impact where the lens comes out of the frame or the lens hits you in the face. So last time I was here, you showed me some other tests. What are those all about?
Yeah, for us, it really seems to be, the weight and the driving force of a rock, for example, that creates the injury, really pushing the lens out of the lens groove onto your face. And so we have a way to really evaluate how much force it takes, how much energy it takes to collapse a lens onto your face, and we can show you that.
Cool. Let's check it out. All right, Wayne. This almost looks like a helmet testing machine that I've seen at different places where something's been dropped. There's penetration tests at the helmet places I've seen. So
yeah, probably
is
not
this
too
similar?
different. Probably not too different. This thing's loaded with a bunch of sensors. We can get force loads, we can get energy loads, we can get displacement. Anything we want to learn about the goggle chassis, the goggle lens, this equipment will tell us. And so we've already done some of the work, and we know how much energy it takes before the lens will actually hit your eye. Okay, and we're going to show you that exactly. And it happens to be roughly 3 joules of energy. That doesn't mean much, but in the end we can equate that to force, and that tells us how much force we need to design into the chassis to eliminate this type of impact.
Meaning how rigid the chassis is?
Yeah. The way we hold the lens, how rigid the chassis is, and obviously lens design plays a big role. So we have some paste or some putty on the orbital here. I don't know if you can see that. That's how we know if we get touch off on the inside of the lens. Right? So this gives us real hard, true data of the goggle system's ability to really protect your face from impact.
So where this putty has made a mark, that is where the lens actually touched the dummy head's eyeball, right?
Touch your eye. Yep. And if that was coming any faster, with say the same weight, then that's a potential injury that we're trying to solve.
And it also dimpled the lens for you.
Yeah, pretty big. Okay, so if we do that same test with Mayhem Pro. Mayhem Pro being our high impact lens.
Hey, no putty.
Yeah, no putty on this guy. You can see where we hit it in other areas already, but we've already done the math on this and done the testing, and it takes 33% more energy to get the same type of touch off on this. So can we say this is 33% safer? We can confidently say that.
Would you say it's due to the frames, or not the frame, the lens's thickness, or the pre-curve, or is it just the way the chassis is built? Combination of everything?
Yeah, it's definitely both. The thickness makes a big difference. The thickness alone gives you about twice the strength as a Lexan lens does, but really that molded curve plays a big role in how stiff the lens is.
So the Mayhem has been relaunched with this frame. You can no longer get the standard Mayhem, right? So it's the air brake is the flagship goggle, and then this is right up there with it then.
Yeah, we launched Air Brake, and the price point shocked a lot of people. We firmly believe that there's enough in that goggle that it warrants the price. But for the guy that couldn't step up to air brake because of price point, this is a perfect opportunity for you to get a better lens, a safer lens, better performing lens for both optics as well as anti-fog. And it's going to launch at $100 on 9/1.
All right, Wayne, one more piece of testing equipment, and this one looks really scary. like a Saw movie or something. But why don't you tell me a little bit about it?
Yeah, this is something we really put together with some existing equipment to really understand how much force can we subject a goggle to and have the lens impact your face, creating an injury. And this is something that we'll use the data to design goggles, design better chassis, use better materials, and such as we move forward. So, valuable piece of data for us.
Okay, let's check it out.
If we look at the same traditional goggle, being a Lexan goggle, and we're gonna essentially compress that lens all the way to the face. So the last test gave us an energy data point. This is gonna tell us how much actual force, pounds force. Okay, so we get a nice graph here, tells us what's happening, and we see a little dip in our profile here, and essentially that's chassis compressing, and then yielding essentially, and then the lens taking over. And so if we look at the pounds, we got a little over 20 pounds, 20 and a half pounds of force to compress that lens onto your head.
Okay, so we saw 20.5 pounds of force for the standard Lexan lens. Can we see what Mayhem and Air Brake do?
Yeah, we loaded up Mayhem Pro, ready to go. Okay, so we obviously have two different profiles here. Mayhem Pro versus that Smith goggle we looked at. And if we look at the force loads, 49.5, so more than double.
Is this the curve of the first goggle?
That's the curve of the first goggle. Here's the curve of the Mayhem. You see really consistent lens frame interface.
What's interesting to me about this is that is the chassis on the first goggle, and it's a really smooth arc on the Mayhem Pro.
Yeah. So we're designing goggles and lenses to really work as a unit. That's the goal. Okay, and again, a third profile. You see the profile is very similar between Mayhem Pro and Air Brake. A big difference is the Air Brake chassis and how we secure the lens, being front mounted, no keyways. So the system works way better overall as a unit, as a system. And our force loads, 75.9, so 76 pounds essentially. So more than triple a traditional Lexan lens.
And I noticed one of the first impressions I got of the Air Brake when I first got one was how stiff the chassis was. Yet it's still comfortable and conforms to your face because of the foam, but the stiffness of the chassis is actually a safety. It's built in for safety, right?
Yeah, for two reasons. We want to house this lens in its correct orientation for optics. If we have a center frame that's really flexy, then we're actually distorting your vision. And the second part being obviously nice and rigid for safety. And what you're feeling when it comes to comfort and fit is the faceplate is actually pliable, not just the foam, but this is designed to move and conform to give you that seal.
Okay, so the Mayhem Pro launches September 1st. It now has the high impact lens technology built in. It's got a larger channel, so obviously you cannot stick one of the new lenses in an old existing Mayhem or vice versa. I guess, what else? Tell me a little bit about the Mayhem Pro that's coming out.
Yeah, you really hit it. We had to change the tooling to really accommodate the lens. Other than that, if you are a Mayhem fan, a Mayhem user for fit and performance, then you're going to be even happier with this new lens for the enhanced vision when it comes to the optics, for the drastically improved anti-fog coatings, and obviously we've proved to you today that it's a much, much safer goggle.
The Mayhem Pro that you gave me a couple weeks ago, I rode in it, and I could definitely tell the vision is better in it. Obviously, the nose piece is gone off of this goggle. I really like the Mayhem because it has a nose piece and it protects my little flat, petite, dainty Japanese nose. So, hey, thanks for having us in, and thanks for sharing some of the testing and the technology with our viewers. And guess what? Go to oakley.com for more.
Yeah, that's right. 9/1. This will be available online and shipping to your dealers.